Hi, in this video I'm going to go through the major steps of radical chain reactions, and many radical reactions will proceed via this chain mechanisms and the steps in a chain reaction. So there are three main steps in radical chain reactions. Step 1 is initiation. Step 2, propagation. And 3 is termination. Now, in the last video, I went over 6 of the common patterns you see in radical reactions. And these patterns are going to fall within these steps. So say one of the reactions that happens during propagation might be a hydrogen abstraction. In the initiation step, very often the reaction that occurs is a homolytic cleavage of a bond. And in the example I'm going to give to go through each of these steps, that's what's going to happen in that initiation phase. So here, the example I'm going to use of the reaction will be So we'll have this reaction catalyzed by light. So that's the entire net reaction, but you'll see there's steps, especially part of the propagation and initiation phase, that you don't necessarily see looking at this net reaction that happen in a radical chain reaction. So step 1, initiation. In this reaction, the initiation step is a homolytic bond cleavage of bromine. One electron moves to each of the bromine atoms to give you two, atomic bromines. Usually you'd find it in the diatomic form, but the light catalyzes it to give you the atomic bromine, just monoatomic, if you want to be more specific. And in the initiation phase, the initiator spelled initiator wrong. The initiator is usually low in concentration, right? It's almost like it's a catalyst, right? It's not a catalyst, but you need low concentrations of the initiator, which is the monoatomic bromine, to start that chain reaction, right? And then once that chain reaction begins, you have the propagation phase. So phase 2, propagation. And depending on the radical chain reaction, you can have a lot of reactions take place in the propagation phase. So here, we have one of those monoatomic bromines, and it will react. I'm going to draw in the hydrogen there because we're going to have the radical reaction take place there. Right, so those are the fishhook arrows we'll draw. The bond between the carbon and the hydrogen, one electron goes to form a new bond between the bromine and the hydrogen, and the other one now forms a secondary radical. So we get HBr, and then our radical. Now, step 2 of the propagation, we have our radical, and we'll react it with diatomic bromine, right? We still have diatomic bromine around, right? One of them, or many of them, were affected by the light, and that light underwent homolytic bond cleavage, but you're still going to have diatomic bromines around too. Whether two monoatomic ones react to form diatomic again, or some of them just never had enough light hit it to catalyze that homolytic cleavage. So you still have the diatomic bromine. So we're going to form the bond between the carbon and the bromine, and then the other electron will go on to the other bromide to give the one product we're looking for, and then the monoatomic bromine. So notice here that if I were to sum up the steps of the propagation and cross out things that appear on both sides, that radical would cross out, the radical bromine would cross out, and I'd be left with Br2 and then our product. So it's the net reaction that we saw initially over here. The propagation phase, your intermediates will cross out, and you'll be left with the net reaction when you sum it up, right? So that means you know you did the propagation steps correctly if everything is crossed out. Now, a few other things to note about the propagation. Each propagation step has only one radical on each side of the arrow. There's never more than one radical because those radicals would react with each other, and then we'd be left with no more radical. The chain reaction stops. So there's always going to be one radical on each side of the arrow. Then also, the product of propagation step the radical one specifically is radical reactant of the next step. Right, this is only a two-step propagation here. You may have propagations that are much more. But initially, the reactant radical is the product of the initiation step, the radical bromide, and then the radical reactant of propagation step 2 is the product of step 1. So that's another thing to check when you're doing these propagation steps. You need to make sure that that is the case as well. And then 3 is termination. Termination is the only step where two radicals react. Because this is the step where you're terminating the chain reaction, and the only way to do that is remove the radicals. So I've got my radical hydrocarbon here, reacted with the radical bromine, to give our product, right? So that is the termination. And there may be other radicals that react together in this final step, right? You could have bromine and bromine react together because there's a lot of radicals around. You could also have two of the phenyl radicals react with each other to give that as a product, right? And just number the carbons here. 1, 2, 3, 4. 1, 2, 3, 4. Yeah. So any of those could happen in the termination step. So you'll have a number of radical reactions that will happen in that final step. But biggest takeaway here, during the propagation phase, you never have two radicals react with each other. One radical on each side of the arrows, and then once you get to the termination phase, that's when you have the radicals react together. And then with the propagation phase, again, you sum up the steps in the propagation to give you your net reaction. Alright, so my next video will be another radical chain reaction, this time specifically with the formation of polymers through polymerization.